Welcome to this introduction to the INTUITEL system. In this video I will give you an overview over the theoretical basis of the INTUITEL system, and I will show you how it will work in practice. INTUITEL is an abbreviation for Intelligent Tutoring Interface for Technology-Enhanced Learning. As the term suggests, it simulates an intelligent human tutor who interacts with the learner. Its major ability is that it is adaptive. The term adaptive refers, for example, to the topic of what is to be learned, the progress that the learner has made so far, the abilities or disabilities that a learner has, the media type of the learning object, the mobility, so for example if it is a desktop or mobile phone or a iPad that the learner is working at the moment, the age of the learner, the culture the learner comes from, and the personal learning style of the learner. We call these the didactic factors, and the INTUITEL system associates the learning material with these didactic factors and on this basis calculates an individual learning pathway for the learner. This enables INTUITEL to simulate a virtual tutor that instructs the learner based on learning pathways, which results in a reorganization of the presentation of the learning material in real time. Now let's have a look at the theoretical basis. On the top level, the learning material is embedded into a pedagogical ontology. This ontology was originally described by Norbert Mieder. Norbert Mieder derived this ontology from studying didactic and organizational patterns of learning material from the past to the present. Mieder's ontology, therefore, is based on a solid empirical basis. The pedagogic ontology underlying INTUITEL subdivides learning material in a hierarchy of components. At the lowest level, we find atomic learning objects, which may be texts, videos, tests, exercises, and so on. At the next higher level, there are learning units, which comprise sets of learning objects. The third level represents courses enclosing sets of learning units. The fourth level contains topics, which are sets of courses. And finally, the highest, most abstract level represents knowledge domains comprising sets of topics. We call level 1 to 3 the micro level, also called the knowledge and media type level. The highest two levels belong to the macro level, also called the subject and competence level. These components are described by metadata, like those that describe the subject, such data that describes the competence that is to be achieved with a specific learning object or learning unit. Another kind of metadata are the relational ones that describe subject relations between learning units or didactic relations between learning objects. Another kind of metadata are those referring to media types, which can be presentation media, interactive media, or communication media. And finally, knowledge-related metadata, which comprises questions about what, why, how, and where, which means orientation knowledge, explanation knowledge, action knowledge, or source knowledge. This leads us to the main problem that INTUITEL is faced with. By assigning metadata to learning items, the learning content is distributed over a semantic network in multiple dimensions. This network must be transformed into a linear sequence called the learning pathway. In general, there is more than just one pathway through this network, and the learner may or may not follow the guidance of the INTUITEL system. Suppose at a certain point the learner chooses a learning object not fitting the current pathway and continues that way. Then INTUITEL will either guide the learner back to the current pathway or compute a new pathway, just like a GPS navigation system. Now let us see how the pedagogical ontology is concretely implemented. The knowledge domain equates to a course. A course contains so-called concept containers, representing lessons belonging to a course. Within that concept containers, we have atomic learning objects representing the concrete content. These elements are interconnected by particular semantics. On the macro level, we have knowledge domains containing concept containers. Metadata define the relations between concept containers, such as hierarchical relations like top-down, bottom-up, new to old, or old to new relations. On the next lower level, knowledge objects contained by concept containers are interconnected in a similar way with relations defining, for example, inquiry-based learning, multi-stage learning, concretion, or abstraction between learning objects. We will now learn from a concrete example how this works in practice. We choose the topic General Didactics containing courses on Comenius and Balauf. The courses are represented by concept containers, which on the macro level may, in this example, be ordered hierarchically or chronologically. For this example, let us assume the learner chooses to learn hierarchically, starting with Comenius. In the first course, we have 4 lessons and possible learning pathways between them. Within the lessons, there are several learning objects of different media types and also, on the micro level, possible transitions forming pathways. The learner may follow any of these transitions, leading him to the next learning object. At this point, he may, for example, choose between multi-stage or inquiry-based learning style. In order to decide which learning objects are to be recommended to the learner, the INTUITEL system also takes the didactic factors into consideration. After he has worked through this lesson, he might come to a lesson containing questions about the previously learned contents. Then he may continue with the Balauf stuff in the same way. Let me now show how the respective tutorial guidance works within a particular learning management system like Ilias. By the way, INTUITEL is not only restricted to Ilias, but can also be implemented for any learning management system. First, there is the INTUITEL system itself, which is connected to the learning management system via the Internet. The INTUITEL system holds a representation of all learning objects that are present in the learning management system, including semantic metadata that associate these learning objects to each other and to a pedagogical ontology. When the user opens a learning object within the learning management system, the INTUITEL system is notified about this event. Based on the pedagogical ontology, the semantic relations between learning objects, the learner's learning pathway in the past, and the didactic factors, the INTUITEL system presents a list of suitable learning objects the learner may choose to do next. In Elias, for example, there is a pop-up window that appears when there are recommendations available. The learner may then choose from the presented list and is navigated to the next learning object. Additionally, textual advices and interactive forms asking the learner for actions may be displayed. At this point, remember our example about general didactics. On the micro level, within a lesson, the learner may have just finished, for example, a video item. According to the possible transitions between the learning objects, the learner may now be advised by INTUITEL to navigate to another text item or to finish the current lesson and go to the next lesson. Then, on the macro level, the learner may be asked if he wants to do the next lesson by multi-stage or inquiry-based learning. Then, the guidance continues on the micro level of the chosen lesson. Let us now figure out what makes INTUITEL unique and what makes it different to other approaches in the past. There has been a long tradition of instructional design theory dealing with how to transform learning theories and didactical strategies into computer-assisted instruction. To give a very brief and rough overview, it started with the behaviorist concept of reinforcement learning. The result were teaching machines like those of Skinner and Pressey. Later, cognitivism and constructivism enhanced the behaviorist concepts. Through all the time, instructional design theory was about encoding instructions in the form of sequences of learning material, built upon the respective learning theories. The major difference to INTUITEL is that instructional design is not fixed or hard-coded in INTUITEL. Rather, it is laid down as pedagogical and didactic knowledge in the form of ontologies. The ontologies, in turn, are created by the authors that create INTUITEL courses. These might be professionals from the field of didactics and pedagogic. They are the ones that create the ontologies and learning pathways. The great feature coming along with this is that the authors do not have to be familiar with the technical aspects. So, INTUITEL can be seen as a framework with which any desired instructional design can be created. Actually, INTUITEL does not encode instructions. Instead, it is situated on a meta level and encodes knowledge instead of instructions in the form of ontologies. The creation of instructions is done generically at runtime through reasoning on those ontologies.